Hello, we are team number 4, and we are going to talk about our methodological research of our project. And our team is Héctor Carrillo, Omar Macías, and me, Alberto Flores. Our hypothesis, talking about the basis of the project and the objective, it is possible to predict a great benefit for the planet, since carbon emissions are reduced. Thanks to that, we help the environment. Thanks to efficient energy, unnecessary energy use is saved in large amount in homes, so we expect a great benefit in houses and in the environment.
Well, the independent variable is what we change or control in the experiment. The dependent variable is what we're testing and will be measured in the experiment. And the control variables are the one that we keep the same during the experiment to make it fair test. In this case, we're going to be measuring what happens if we change the current and if it's going to affect the voltage. As it can be seen as the independent variable increases, which is the current, or dependent variable, which is the voltage increases. And as well, our control variables will be the material, the length, the cross-section area, and the temperature of the wire.
Well, for the material and resources, the materials we're gonna be using are Arduino Uno for the hardware that will support the software and the program that we'll be making, the relay to control the voltage of the current, a protoboard to literally put all the components in it, the LEDs to represent if it is working properly, the cables and resistance to connect everything, an AC adapter to pass the current into another object that will be connected, a plug for the AC adapter, and a button to start or off the, the object. Then extra materials will be a multimeter to measure for the measurement of the electricity current and a computer to pass the program into the Arduino Uno. Then the resources that will be used is only the electricity well.
Well, in the control group, we're going to be having 3 Arduinos with the same charge of current. All the Arduinos must be built different, whether for changing the material or the way it's programmed, so we can see which one produces less voltage and works perfectly fine without giving us any type of problem. In the experimental group, we're going to put the same 3 Arduinos with the same materials, just changing the current to see how does it affect the voltage and if it's better to have more current for best working and efficiency for the Arduino, or is best to have less current for less electricity production.
Well, then in the methods, the first is the data simulation software of Arduino from a US university. It's gonna be used for testing the connections to be the way it is expected. In this case, specifically of the LEDs and the Arduino. Then in the second place, another simulation software such as Tinkercad will be used for the previous test, but now we're gonna put all the elements together, and also the program of the Arduino will be tested. Then in the third place, the replication of the simulation in Tinkercad, but with all the components that we have in our house. Then the program will be passed to the Arduino to work as expected by the computer. And finally, we'll begin the test with the electricity current and measure the current. And also the LEDs will be checked to see if the current is working properly and the way we want.
Well, in the sample size, our sample is to test if the necessary amount of energy is given. And this sample size, well, we're going to repeat this experiment of the sample between 5 to 6 times approximately. The next one. In the repetitions, we are going to have like some steps. In the first step, we are going to do some tests in a simulator until we obtain positive results in the simulator. Um, then, in the second step, we are going to start making physical tests with the same elements as in the simulator until we have the results we expect. And in the third step, we will repeat this test until the programmation, the connections, and the robotics be well done. Well, this is all of our presentation. Thank you for your attention.